For homework 15, and we're going to do acceleration analysis. So here is problem 1, and we have a this bar that is moving with a velocity b to the right, but it's decelerating with acceleration b right here. It's on a slope that's 45 degrees, but the bar itself is 30 degrees. So we want to use vector math and determine the velocity and acceleration of point A. Okay, so I'm going to pause so I'll write out the problem instead of wasting your time. Okay, so here we go. Right here, I have written out the problem so that I didn't take up time of yours. So when we do vector math, we want to make sure that we write out all the things that we know here. We'll say that first off, the velocity of b is equal to 20 I, right, meters per second. The acceleration of b is going to be equal to negative 5 I meters per second squared. Other things that we're going to need to do, well, first off, we'll do the velocity analysis. We'll say the velocity of A is going to be equal to the velocity of B plus omega AB K crossed with R, and it's going to be A with respect to B. All right, so it's in our interest to maybe write out RA with respect to B separately. And so it's going to the left and down. So both are going to be negative. So it's going to have a negative 18 and boom, boom. We're going to make sure we're writing this right down right here. It's going to be the cosine of our 30 degrees, right? Yeah, 30 degrees coming down, yeah. I plus, or actually I could have written minus, right? I guess sometimes I put the minus sign inside the parentheses, but I'll go ahead and put it right here. Minus 18 sine of 30 degrees J. And these are inches. And I put meters per second up here for some reason. Let's figure that out. Get it straight, kid. I hope the original problem, I didn't write that anywhere. No, I kept them. Okay. Might have been a reason for having done that. Okay. So let me write out what the values are to there. Try not to be so scatterbrained. I feel so scatterbrained lately. Jeez. Negative 15.59 I plus 18. That should just be negative 9, right? Inches. Okay. And we're just going to leave omega as being positive right now. Now, chances are it's going clockwise, but we'll just demonstrate that we can establish that it was going to be that it will be if we assume that it's positive, that we're going to get the correct thing. Okay, so here in the another thing that we might want to do is write out VA as being all right, so here's like an important thing. Maybe I wanted to put this up earlier right here, but let's say that we recognize that VA is going to be equal to VA times, and let's see, I'm gonna say that the angle is coming based on this direction right here. So this is theta right here. That it's going to be so therefore it's going to be in the x direction. It will be like the cosine. It doesn't really matter, I guess, when it comes to 45 degrees, but I wanted to get this right. And sine of theta j. Okay. I was thinking about maybe I should have kept all that stuff in, but I can go ahead and write that this is going to be 0.7071 VAI plus 0.7071 VAJ. So when I go to fill this in right here, I say VA, let's see, write this out the right way, 0.7071 VAI plus 0.7071 VAJ is going to be equal to 20I plus omega A B times my 18, or excuse me, negative 15.59 K crossed with I plus my omega AB negative 9 K crossed with J. So that's negative I, and this is J. So I'll rewrite that thing out here. 0.7071 VAI plus 0.7071 VAJ is equal to 20I. And I guess I'm going to write, let's write it in this order here. Plus omega AB 9, because I got rid of that negative and negative, I plus omega AB negative 15.59 J. Now I combine the I's. And we see we have 0.7071 VA is equal to 20 plus omega AB 9. Okay, so we have two unknowns, but we can go to J and say 0.7071 VA is equal to 0 plus, and I guess I'm just gonna, I'll keep it in this order, 15.59, right? So we can stick in, and we could say, we could solve VA is equal to negative 15.59. Well, let me keep the negative inside the parentheses just for a little bit longer. Divided by 0.7071 omega AB, or a negative, so 15.59.7071. In fact, actually, let me go 45 cosine. Divided, and we get a negative 22.05 omega AB. Put him back up into this up above, and 0.7071 times negative 22.05. Of course, we just divided, so we're going to multiply, but that's okay. Omega AB is equal to 20 plus omega AB times 9. we'll get omega AB. Let's see if I can get that up in there. Omega AB is going to be, let's see, 0.7071 times, yeah, we just get that, and it's negative, and so this is going to come over to the other side, and it too is going to be negative, so we're going to add that 9 to there, and then we're going to divide 20 by it, but it's still going to be negative, so we get a negative 0.8133 radians per second. So therefore, it is going in the reverse direction, right, from what we want. But we'll keep this as negative and put it back up into, let's put it into this. And we can find that VA, the magnitude, is negative 22.05 times negative 0.8133. So 22.05, and we get positive 17.93 inches per second. So that's the magnitude of the velocity. So now we're going to use this to find in the second part of the problem, right, which is to identify the acceleration. So many of the same things are true right here. We need all that. We need that position vector. I think we have everything we need. Now, so we're going to write the acceleration of A is going to be equal to the. Let me back off a little bit so it doesn't. So I want to go out of focus based on my hand being so close. Acceleration of B plus. I'm going to double check. I think I go acceleration first. Crossed with R should be A with respect to B minus omega AB squared times RA with respect to B. Right, so we have more things. And we note that the acceleration of A should be we're gonna select that it's coming upwards, this right here. I think I'm gonna go positive, and then we'll just see what happens right here. So it's gonna have and it's gonna be in line with this theta right there. So we're gonna say acceleration of A is going to be the acceleration of A times the cosine of theta I plus acceleration of A sine of theta j. So once again, it's going to be, which order did I put this in? Did I put the accelerated, when I put the velocity in there? No, I want 0.707. 0.7071 acceleration of A I plus 0.7071 acceleration of A j. Also, okay, no, we already wrote what the acceleration of B was going to be. Okay, so let's start writing this thing out. Let's start filling this out right here. So we got the acceleration. I'll write it out the same order I had it up here. 0.7071 acceleration of A plus 0.7071 acceleration of A I j. It's going to be equal to, and we're going to assume this is, oh, okay, no, we already have this, yeah, so it's going to be a negative 5 I, and then plus that times the first part of our position vector, which is negative 15.59, k crossed with I. We know that's going to be a j. And then I'm going to continue down here with alpha AB times R negative 9 k crossed with j. I probably could have fit that back up on there. And then still continuing here, we're going to have a negative 0.8133 squared times, where's my R? It's going to be negative 15.59 I, and then lastly minus 0.8135 squared times our J position vector thing here. Let's see, come back. So that's going to be negative 9. And that's J. I think I got it right. So let's collect the terms. Okay, this is going to be a negative I. So let's write 0.7071 I plus 0.7071 J. It's going to be equal to negative 5I. And then you're going to have a negative 9 here, so let's go plus 9 alpha AB. I don't know why I just swapped the order of it, but that's okay. And then we're going to have a plus negative 15.59 alpha. I guess I swapped it. Might as well keep swapping it right here. Yes. Oh, and man, sorry. I, J. And then let's actually do the math right here. We got 0.8133 x squared times 15.59. And this is negative and negative, so we're going to be plus 10.11 I. And then there's a negative and a negative, so that's nice. So we have 0.8135 squared 9. And so we get plus 5.956 J. And so now we're going to collect the I together and say 0.7071 AA is going to be equal to negative 5 plus 9 alpha AB plus 10.11. So we can simplify this a little bit and maybe even set it equal to right here. So we could say that AA is going to be equal to, we'll take 5, but we can take 5 and subtract it from here, right there, right? And divide that by 0.7071. And I'm going to get 7.232. And then I take 9 and divide it, and I get 1.2, nope, divided by 707, it should get larger. 12.73 alpha AB. So that's equation 1. And then J, 0.7071, acceleration of A. There's nothing for this one for the J, so we come over to here and we get a negative 15.59 alpha AB. And then lastly, a plus 5.956. So let's solve for the acceleration of A. And so I'm going to divide, I take a 15.59, divide by 0.7071. So I get 22, it's going to be negative 22.05 alpha AB plus and 5.956 divided by 707 is 8.423. So this is a second equation. We can set these equal to each other. 7.232 plus 12 point, so I'll write equate 1 and 2 right there, and 7.3 alpha AB. It's going to equal to negative 22.05 alpha AB plus 8.423. Okay, and I hope I didn't make any stupid mistakes. But if I bring this one over to here, right, that's going to have, they're going to add together. 12.73, we're going to add them. And then this one over here is going to subtract, so I'm going to take my 8.423 and subtract out 7.232. Boom. And I'm going to divide, and I get an alpha AB equal to 0.03425 inches, radians per second squared. All right, so my next thing is to take this alpha and put it back up into either one of these two lovely things. And I think it's better. It should be a positive number right here, right? So even if I put it up into this one, so I try that out. 22.05 and multiply, and so that right there is going to be negative though, and add to the 8.423, and I'm going to get an acceleration of A is 7.668 inches per second squared. So what we can say here is that the velocity of A is equal to 17.93 inches per second, and then 45 degrees. And acceleration of A is equal to 7.668 inches per second squared, also at 45 degrees. And I can hope that I didn't make any stupid mistakes. So I'm going to pause this and check it, because there's so many opportunities to have made a mistake. I will try to use other methods to double check. So I'll be right back in our long 23-minute video, 24-minute video. Okay, so I checked with, I even used SolidWorks there, so you caught me. I checked with using the ICR right here, and I got the same angular velocity and the same final velocity there. And I think I have pretty good confidence that this is the answer. So let's go on to the next one.